All right, thank you. Okay, so anyway, the objective. We want to become familiar with 3 of the 6 inverse trig functions. Now, this is kind of an old school way of writing it. Arc sine, arc cosine, arc tan. Same thing as inverse sine, inverse cosine, and inverse tan. And we do the -1 symbol. It's not 1 over, mind you. Please don't do that. It's not 1 over tan x. What would you have to do to write as 1 over tan x? You have to say tan x in parentheses, then raise to -1. That's how you would show that. But when a -1's next to the trig function, it's actually implying an inverse trig. Kind of like you guys have seen this. You guys have the inverse function, right? It's a notation thing. So make sure you're clear on that. So that's important. So we don't navigate that too. Okay. So horizontal line test is gonna be a big deal because we want these inverses to be functions. Because in general, like what sine looks like this, right? Sine's a bunch of curves like that. Does this pass the horizontal line test? No, right? It fails it so many times. So we have to restrict. We're gonna have to restrict the domain so that we can have the inverse be a function itself. So it could pass the horizontal line test. So we are gonna have to do that. But very important that you guys remember that f of g of x equals x if f and g are inverses, and likewise g of f of x equals x. Again, when f and g are inverses. Now the domain of f is the range of g. The domain of g is the range of f. So let's graph sine first. Sine looks like this, right? Starts at the origin, hits peak pi over 2, hits the middle of pi, hits the low point 3 pi over 2, back to the x-axis here. Right? And we'll do the other side as well. Okay. Now, this does not pass the horizontal line test. So you want to force the issue. You really want this to pass. So for what interval we'll have an inverse? And here's what I'm going to draw. Did you guys draw inverses last year? Oh, okay. So it should be a review. Oh, bless you. There you go. That's what you want to limit. Because if I just focus on this part, now does it pass the horizontal line test? Yes, right? So you want it, of course, do I have to limit it like that? No. Could I have done this instead? I could have done that, right? Or could I do this? Yeah. Yeah. So many ways you could do this. So the first way that I did it is actually not the default range or default domain for the sine function. The default range is going to be this instead. We're going to do that instead. So you're going to say the interval for which we have an inverse is between negative pi over 2 and pi over 2. So I'm going to restrict the domain of sine like that, meaning that the range of the inverse sine is going to be restricted like that. Because remember, what is the output for inverse? It's an angle, right? The output for sine is a coordinate or a ratio of two sides. But the output will be the angles. It's reversed, right? It's the inverse. For inverse sine, your output's not the angle. Your output's your input's not the angle. Your input's the coordinates or the ratio of sides. The output's the angle. So this is going to be the default range. And why people chose that, I don't know. Maybe a bunch of mathematicians got together and say, oh, let's just do this as the default range. Seems simple, it's in the middle. I don't know. But it's the default range for inverse sine. Just, you know, that's the default range. Okay, let's look at cosine and tangent. Okay, cosine, let's graph cosine. Cosine looks like this. Starts at a peak, goes here, low point, middle, high point. Easy enough, right? Okay, we're good? That's cosine, right? And obviously this fails the horizontal line test. So we need to restrict the domain somewhere. Like I could do this. I could do this. I could do this. Or I could do this. There's infinite possibilities. Which one do we use for the default? You guys remember? Yeah, 0 to pi. Exactly. That's the default. Again, this is the default range. Reverse cosine. Okay. And then lastly, for tangent, let's look at tangent here. Asymptotes. 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 Okie dokie. Sorry, my tangent looks sloppy. My apologies. I could do better. That's all right. So clearly this fails because it's a repetitive function or periodic function. It just keeps repeating itself. This fails the horizontal line test so many times. We have to restrict it somewhere, and one of these curves would be good enough, right? Like for example, this would be good enough, right? Is that the default range? Yep. Yeah, the middle is the default range. Now, am I going to include negative pi over 2 and pi over 2? No, you do not include it because it's undefined there. And that's going to be the default. So it's very similar to tangent, sorry, to sine, inverse sine, but doesn't include it. Okay. All's good? All right. As I mentioned, arc sine, inverse sine, tomato, tomato, same thing, right? So let's fill this out. Actually, let me readjust here. Okay, here we go. Okay, clear. We got x, y, x, y, x, y. Now, very important. The output is the angle. The input are coordinates from the unit circle. So the inputs would be like, for example, I'll do -1, 0, 1. And let me draw a makeshift unit circle over here. Okay. 1, 0, 0, 1, 0, -1, -1, 0. Okay. So if you inverse sine is 0, so basically if you inverse sine is 0, where's the y coordinate 0 in the unit circle? It's 0. Yep. Where is the y coordinate in the unit circle 1? Pi over 2. Where is the y coordinate in the unit circle -1? Yeah, or 3 pi over 2, but we're going to say negative pi over 2 instead. And there are, of course, there are infinite possibilities. We'll say negative pi over 2. Now, inverse cosine. Remember, this is okay, these guys are the x coordinates on the unit circle. Okay. Where is the x coordinate 0 in the unit circle? Pi over 2, yeah. Also 3 pi over 2, but we'll say pi over 2. Where is the x coordinate in the circle 1? 0. Or 2 pi, but we'll say 0. And where is the x coordinate on your circle -1? Pi, right? Okay. And then here, your You're looking for y over x, right? So y over x. Okay. So where's y over x going to be 0 in the inner circle? Probably right there. So 0. Then this is going to be in between the first or fourth quadrants. Where is the ratio of y and x coordinates on the inner circle going to be 1? Pi over 4, exactly. And then negative pi over 4 for the other one. Or you could say 7 pi over 4, but we'll say negative pi over 4. Okay, with the table, now we can do the graph. We'll see the graphs down below. So I'm going to put 1 and negative 1, 1 and negative 1, 1 and negative 1. And I'm going to do pi over 2. Gosh, really hard to sneak in here. Okay, so let's draw this. I have a point here, here, and here. So it's going to look kind of like this. You have a point here, here, and here. So it kind of looks like that. And this one, you can have these horizontal asymptotes, believe it or not. There's a point -1 comma negative pi over 4, 0, 0, 1 comma pi over 4. It looks like that. Now, technically speaking, the inverse sine graph looks like this. You keep drawing more of these curves. Okay, I'm doing a crappy job drawing it, but there are more of those, right? But because we restricted the range, this forces it to be a function, right? If I repeated all the other ones that go above and below, we would pass a vertical line test. Now, because you had to pass a horizontal line test from the original, so that you pass a vertical line test for the inverse. So you don't want to repeat. This is repetitive. It's periodic, totally. You're only going to show a portion of it to guarantee it's a function. Likewise here, there's a bunch of curves that look like this. But we want to pass a vertical line test, we don't draw it. To restrict the domain of the original, meaning the range on the inverse is restricted. Likewise here. There's doing more of these here, right? Again, so many more of those. But we restricted it so it passes the vertical line. Okay, so this is kind of the foundation of inverse trig graphs. We're okay? Do good? Yeah, cool. Yeah, it would not be, yeah, it had one like this. How could it just be like this? Shouldn't it just be like no, it's not continuous at all. Yeah, you have. Yeah, no, it's this goes. Oh, I see what you're saying. Oh, wait one sec. Hold on. You know, actually, you're right. Sorry. You're correct. You're correct. I did draw that incorrectly. Yes, you're right. Sorry. It's time like this, right? Yeah. Yeah. My bad. I was thinking, yeah. I don't know what I was thinking. No, it's weird. Well, long line is you want to pass the word like this. That's good. Yeah. So let's do one. No, you're correct. I was thinking something else. I'm not sure what I was thinking about. Okay, let's keep moving. Oh, domain. Let's see that as well. So domain's going to be. I'll do a different color here. I was getting a little busy. So domain's going to be -1 to 1. And of course, the range is negative pi over 2 to pi over 2. Same thing here. Domain's going to be -1 to 1, because that's the range for the original. The range is going to be 0 to pi over 2. Sorry, 0 to pi. And lastly, the domain is going to be all real numbers, just because the range is all real for the tangent graph. The range will be -pi over 2 to pi over 2, non-inclusive though. So you do parentheses, not brackets. Okay. We're good so far? Cool. All right. Let's keep on trucking. All right. So let's look, just to summarize, the domain is going to be -1 to 1, -1 to 1, and negative infinity for inverse tan. The range will be
wouldn't it be the opposite? Because it's for sine, not like the inverse.
What do you mean?
Like, wouldn't it be flipped? Like
Between these two? No.
Like the range of sine would be -1. Not.
No. No. This is the domain. We're doing inverse.
No, but it says if sine, not the inverse.
Oh. Wait, I'm confused.
If sine is
If
if sine
the-
y is x.
Yeah. So y equals inverse sine of x if sine y. Yeah, because obviously when you have y equals. Yeah. No. Think about it.
Oh, that is the inverse for sine.
Yeah, because we switch x and y.
I see that one.
No worries. No, you have me worried. I thought, was this wrong? That's good to question me. Question notes. And then lastly, this is so we're okay, Oscar?
Yeah.
Okay, good. Okay, so there we go.
I confused one.
Okay. Let's move on to the next page. So this is all unit circle stuff, right? All just an extension of the unit circle. So if you think about it, inverse sine -√3/2. So where would the y coordinate be -√3/2? That should be at -pi/3. Got it? Yep. Or you could give the answer in degrees too, by the way, if you want. This one's easy. That's pi/2. Inverse cosine √2/2 should be pi/4. Inverse cosine -1/2, that'd be in the second quadrant. That should be 5pi/6. No. 4pi/3. My bad. No, 2pi/3. 2pi/3. Inverse cosine, because the x coordinate on the unit circle is -1/2. Remember, the input's a coordinate, the output's the angle.
Oh yeah.
Right? It's okay. It's been a long day.
Yeah.
I make mistakes too. Inverse sine of √1. That's the same as √2/2. So 45 degrees of pi/4. And this one, you want y/x to be that. That should be reference angle is 30 degrees, but it's in the fourth quadrant. Should be -pi/6, I think.
Yeah.
Or -30 degrees. Yep. There we go. Yeah, very good. For B over D.
Oh, so that should be yeah. -2/3 works as well.
Right. 2pi/3. Right? What are you saying it should be?
They both work.
That works, but remember we have default range. Our default range is 0 to 0. You are correct, that would work, but
Guys, there are actually multiple, there are actually infinite possibilities, right? There are infinite possibilities. So, so one thing to keep in mind. They're infinite. But we restrict the range. We have to restrict the range. Okay. All right, let's keep on moving. Okay, composition of inverse functions. If you plug inverse into itself, you should get x, right? We know this. Or plug the original into the inverse, you should get x. These are all things we know. So hold on, I'm trying to understand what should go in the notes because these notes are a little different. I think we could. Well, I think it's meant to say this: if y equals,
If psi, wait.
I don't know.
If,
Yeah, I don't know either. Let's just skip it. I think you guys get the point. Let's just skip it. Okay. I don't know.
wait, maybe it's trying to say like if sine and sine inverse are inverses.
Well, there's no.
I don't know. I don't know what's meant by that. Okay, I care more about this anyway. Okay, this is what I care about. Okay, these are fun problems. I like problems a lot. So here's the deal. The one thing, no, not be careful. Be careful. So that represents an angle. So think of it like theta. Think of it like theta. So inverse sine of 2/3 equals theta, right? Let's draw a triangle. Here's theta. Where did 2 and 3 go, guys? Here. And this would be root 5. Now, you want sine theta. What's sine theta gonna be? Still 2/3. So it is the same. That's fine. But it's just a good habit to do that. A good habit to draw a triangle in that manner. And realize that the inside is actually an angle, right? Because inverse trig has outputs of angles. Now this one I know is not possible.
Oh, okay.
Why is that one not possible? Totally. And also, let's just think about basic SOHCAHTOA too, right? Think about basic SOHCAHTOA. This is telling me that inverse sine of 3 equals theta.
Opposite can't be 3 times that.
Yeah, exactly, right. How can the opposite side be bigger than the hypotenuse? So 3 and 1? That makes no sense, right? That's why it's not possible. Yes, there is a default range that we have to, sorry, default domain.
from A1 to 1 and 2, so that here's the thing. Just think about the geometry, right? This doesn't make sense.
In this one class, you said we could just like D&E.
That's fine. But not possible. Yeah, either way.
Okay, next up. Now, cosine pi over 7 is definitely in the first quadrant. I don't know what that is, but they're pretty much going to undo each other. So this is, some ratio. So you're doing inverse cosine of some triangle ratio. Well, guess what? It's going to get you back to pi over 7.
You would only need to worry about that if he wasn't in like X or greater.
Right. Now, this next one's a little tricky, though. Inverse tan. And what's tangent 2 pi over 3? We should know this. This is going to be negative root 3, I think. Is that correct?
I did not do that.
Yeah.
Yeah. Okay. But Why is that gonna be in Q4? Because the inside's negative, right? And remember, inverse tan is from Q1 and Q4, so right half of the unit circle, or the right side of the y-axis. So, what angle are you gonna go with then? Yeah, you're gonna say negative pi over 3. So you can't just assume that these are gonna knock each other out and say it's 2 pi over 3. That'd be so far from the truth. You have to actually evaluate and go through the motions and respect the default range. Yeah,
Oh, so that was for side.
totally. And cosine too. Yeah, 100%. Can. But anything that's not unit circle, like A, you could draw.
Oh, but, so if it's not unit circle, you can just stay there and do each other.
Right. But you may want to draw still. Let's do some more here, and then we're done. Okay, what's sine of 5 pi over 4? That's a negative root 2 over 2, right? But where is that going to be according to the default range? Yep. Oh, F. So inverse cosine negative root 3 over 2, that's going to be in the second quadrant. That's going to be 150 degrees, or cosine of 5 pi over 6, I think.
If we see that it's like gonna be in the first or second quadrant, you just assume it.
Yeah. Mhm.
Even if that's not-
So it's negative root 3 over 2. Well, actually, if it's inverse sine, no, you can't assume if it's inverse sine. The Q1, you could assume that. But yeah, I mean, fortunately, because this is still negative, right? We're okay. We're the same quadrant, so. And then finally, these here. So what quadrant is this going to be in? Q what? What quadrant is this one in? Q4. Good. Okay, so this is negative 5. That's 7. And I'll do this one here simultaneously. Negative 3 and 8. Doing Pythag correctly, root 24 or 2 root 6. And it's positive, it's pointing up. 64 and 9 root 55, which I can't reduce or simplify. And then I want sine. So I'll think of this as theta, and that's like reference angles. So sine of that's 2 root 6 over 7. Next one's going to be tangent, opposite, or adjacent. Wait, what? Oh, okay. Okay, good. I think that's a good place to stop for today. So we have 2 more full days lessons, definitely on Monday and Wednesday. Our test is not until September 27th. I built 2 review days into the schedule for you guys. So just so you know, look at the calendar really quickly before I end the video. So yeah, so I see you guys Monday. We'll do one more part of these notes. We'll finish off notes on the 20th. The 22nd, I'll start giving you guys information about the test. I'll have the test figured out by then. And then the 25th, we'll do another review day. And test will be the 27th. So by the end of the month, we'll have a test. Totally, 100%. Yeah.
Another what? Oh, good.
Right. Okay.
Do we have those math competitions?